All right, late on a Friday, which I think is more or less canonical. All right, yeah. So last time we got this. So what was supposed to happen was, let me pull up the source here. So we were supposed to print the hello string, which is the part that has several spaces and then says to the left, to the left. Then print a line feed character. Then finally print our second part, which just says here. So as you can see, it looks like it pretty much didn't work at all because it went, it printed to the left, and then without returning to the beginning of the line, just printed here. So that's an issue. Let me crack open a beverage. And let's investigate. Firstly, starting to see if there's anything obvious about this being wrong. So if we go to print character, which starts here, and we look for, firstly, let's do some obvious stuff and make sure 0D is, in fact, a 0-byte character, which it is. So that's good, because the first thing that this code does is look up, let us see, 1 second. Here we go. Looks up in the lookup table to see whether the character at that character code is 0, which means that it is a non-printing character. So if it was 0D, then this is 0, and we should skip to check control, which is over here. So first, A should still contain... wait. That would do it. That's simple. That's easy. Our character was an X, because we transferred it to X, not in A. That's what's up here, because compare compares against the accumulator, the A register. So we need to transfer X back into A here. Yes. And hopefully that won't screw anything up. I don't think so, but I think that's our fix. Which still isn't going to look quite right because the string that we're printing is more than 32 characters long, and so it wraps itself onto the next line, which is incorrect. So we're gonna carriage return to the beginning of the second line, not the beginning of the first line. But I'll fix that in a second. But hopefully that was it. Let's run it and find out. Nope, it's still wrong. Super cool. So, one would assume that this check is working now. One would assume a lot of things. That doesn't mean they're right. So we took A, which is the ASCII character print, we transferred it into X. Then we used that as the index into the lookup table and loaded the character into A. And then did branch if equal to check control. We already went over that. And at check control, one would imagine that ASCII character value is still in X. Hey Trey, good to see you on this fine night. Trying to figure out why my carriage return magic isn't working here. Probably gonna have to switch to using the debugger in a second here, but we will see. So we compare it to 0D, which it should be, because we put 0D in the accumulator, so it would be kind of crazy if it wasn't. Actually, let's check for another really obvious thing. Nope, it is hex, and it is an immediate. I was wondering if I got that wrong, but dang, no, that's correct. Okay, so we compare it if they were not equal, if whatever was in A and the literal 0D were not equal, we go to check line feed. but presumably they are. So we load the screen address, we load the value from the screen address variable, which is a byte in the 0 page, which is the low byte of the kind of cursor position in video memory. And we AND it with E0 to clear out the bottom 5 bits, which should be equivalent to the X position on screen. Then we take A, which should be the screen address ANDed with E0. We put it in X, we increase it, then we put it back in A. You know what we don't do? You know what we definitely don't do? Save it back into the screen address variable. That would be an oversight. Let's do that. That's probably... Well, I mean, either one of those would have caused this not to work. Those two together would definitely cause it to not work. Okay, I'm feeling a little bit more lucky this run. Yeah, there you go. Okay, that's correct. So it prints to the left, then new lines automatically, and then prints the rest of left, then carriage returns and prints here. So if we fix up that screen now, I think this is working properly. Let us see. So here's our to the left string. I guess let's just switch it to the left. Fine. And for fun, I'm going to use parentheses for no good reason, but we implemented them, so why not use them? And this should basically end up with here being printed second, but in front of this text, because that is the way a carriage return works. On an old school mechanical teletype, it would return the carriage to the beginning of the line of text. Yay! Okay, so that's working properly. Now, the next one we need to implement is line feed, which should be super duper easy. Line feed should be 0A, but let me sanity check before I commit to that. Line feed should be A. Yes, here we go. Line feed, new line. Might need to implement form feed. Don't know if BASIC uses that. I guess we'll have to check at some point, but not going to do that one right now. But we definitely need line feed, and it's easy. It is easy, because all you got to do is add 32 to the current character, because every line of text is 32 characters long. So therefore, adding 32 increases your Y position on screen. But with carriage return, or with line feed, sorry, you want to keep the X location of the character. That shouldn't change, because again, on a mechanical teletype, what that's supposed to be doing is rotating the platen slightly and bringing you to the next line, but the carriage would stay in the same place. And it's those together that would move you back to the beginning of the next line. Now again, when I get the basic code on here, I don't know that that's going to be what it's expecting, but that's pretty standard, so I'm going to implement that, and if we have to zhuzh it up later, so be it. So firstly, I'm just going to update this code, so we'll do both. Actually, you know what? Let's not do both. Let's start by just making sure that line feed works by itself. And where was that? I've gone too far. We're in the character lookup table. Oh, so check control. We checked if it was 0D. It is not 0D, so I already set myself up this check line feed. Excuse me. This check line feed symbol, label, what have you. And so here, let's see, we put X, which was the ASCII character, back in A, did the comparison, so we should just be able to compare again right there because we still have the value in A. So compare it against hex A, and if it is not hex A, then we just jump ahead to print char end, and yes, good. Print char end doesn't move the character or anything, and we don't want the character to move at this point. It just resets the PPU scrolling, which is a thing that we're going to get into, because if we do scrolling, I'm wondering if I can use the PPU scrolling to do scrolling, but I don't really get how that works, hardware scrolling. The only times I've really done this, I've done software scrolling, which is going to be super duper slow, and I don't think we can copy a full screen of tiles, I have been told, within a single vertical blank, which is going to be a problem. So that's interesting. But we'll burn that bridge when we come to it. But I'm curious to find out if I can make the hardware scroll work for me. Right. So if it wasn't a line feed character, we just bail out. If it was a line feed character, then I'm pretty sure all we need to do is load screen address into A, clear carry out of an abundance of caution, add with carry, hex 20, which is 32, to add a whole line width to the cursor position, and that's pretty much all she wrote, right? Yes. Yep. So we just store it back into screen address for future use, and that's it. We can bail straight out to print character end. So when I do get to scrolling eventually, this is all going to be different and weird, because when you get to the bottom of the screen, you're not, increasing line position anymore. You're just scrolling. So that's going to be funky. But even though we are right next door to it, I'm not going to think about it too hard just yet. Trade MC says, unless you're in Unix or classic Mac OS. Oh, as far as line feed and carriage return. I don't remember what the history is on that, because you used to have to send both, because that's how a teletype mechanically worked. Like, just sending /n that would not give you a full everything on a teletype. So I'm thinking possibly that, if I remember correctly, I think in Unix they just possibly elided the carriage return just for convenience, and I think it automatically would reinsert the carriage return character in the actual stream going to the teletype, but it would be inserted by the operating system. I think that's what happened there. Mac OS is its own thing. Okay, so Trade MC says, scrolling works by showing half the available tiles on the screen at one time. Right, because it shows one of the maps. You can do scrolling, or one of the name tables. You can do scrolling, but you'll have to move the top of the screen that's scrolling off the viewport to the bottom of the screen. So this is why I'm not sure about the hardware scrolling, because I think like the only other thing I'm really semi-familiar with is IBM PC text mode, like VGA text mode. There goes the air. And I think it's possible on VGA text mode that the scroll just wraps. So I think that might be how hardware scrolling works in VGA text mode, is that you can just keep increasing the scroll count and writing to the next location in memory on the what is effectively the the character cells, and it will wrap around memory eventually, so it's just kind of invisible to you because it's like a Mobius strip of memory. I'm not 100% on that, but that's my gut feeling. With this, I know it's going to be weird because the scroll doesn't wrap. Viewport does wrap. Does it? Okay, then that might be great. Because all we really would need to check for then is if we exceed a certain address and then reset the address and potentially reset the scroll to, you know, the equivalent non-overflowing scroll position. I'm sure there's lots of information about this on NES Dev, but let's just run this and make sure what we should get now is we should get to the left, and then immediately on the next line in the same X position, we should have hello, or here. That's what it was. So let's see if that worked. Perfect. So now, if I combine those two together, I should be able to do a full, proper line break. So, where is my main chunk of my program here? Here it is. So I'll just copy this line. Perfect. So it doesn't really matter the order that I do these in, but it should just be that, and we should get it on the new line. Ta-da! Beautiful. I guess that's that. I guess now there's nothing more for me left to do here than to scroll. So, I guess maybe let's start looking at... Because I know, Trey, you're here, you're watching. Sounds like you already have great familiarity with how the name tables and the PPU scrolling work, but I don't. So, I'm going to need to do some looking. Let us see. I guess maybe... I'm not quite sure which area is going to have this. Probably the PPU scroll register info. No, that's the memory map. I want the registers. That's the init code. I may not have this up anymore. Palettes. Name tables. Also, not sure right now which mirroring this is set up to use. Ideally, our mirroring would be vertical, because it doesn't have the extra... It has extra work RAM on the cart, but it doesn't have extra VRAM. With extra VRAM, you can do 4 full name tables, but when you only have the VRAM that's available on board the NES, you can only use 2 of them at a time. And I would want them vertical because I want to, you know, keep printing here and then scrolling down the screen and then hopefully wrapping at the end of the next name table. Yeah, but anyway, we need to look up PPU registers. I think this will be the spot because here we have the scroll register. They have a link to scroll position, so that looks useful. And we're already using it, like I said, briefly, at the end of character printing. This is just setting the X and Y scroll to 0, because apparently when you make changes to the PPU, it screws up the scrolling every time, which is a thing. Trey says, I'm making it up as I go along. I can respect that, Trey. I mean, that's all I'm doing. So, let's see. This register is used to change the scroll position, that is, to tell the PPU which pixel of the name table selected through PPU control should be at the top left corner of the rendered screen. Typically, this register is written to during vertical blanking, so that the next frame starts rendering from the desired location. but can also be modified during rendering in order to split the screen. Changes made to the vertical scroll during rendering will only take effect on the next frame. After reading PPU status to reset the address latch, write the horizontal and vertical scroll offsets here just before turning on the screen. Horizontal offsets range from 0 to 255. Normal vertical offsets range from 0 to 239, while values of 240 to 255 are treated as -16 through -1 in a way, but the tile data is incorrectly fetched from the attribute table. Messed with that a little bit before, and yes, it just does weird things. By changing the values here across several frames and writing tiles to newly revealed areas of nametables, one can achieve the effect of a camera panning over a large background. So I think potentially it's just going to wrap at 239, and we have to be careful to not go past 239. But yeah, here's what I'm thinking as a test. Let's write this string, and then I'm just going to... So what the code is currently doing after it writes that string is it is... Let me find it again. Right, so it prints the first string, prints our two control characters, prints the second string, and then we enter this loop where we are reading from the controller port, doing some bitwise arithmetic on it, and storing it back to the controller port, which is just it was a way for me to check that code was running on the thing in the first place. And then it just loops. So, how about we do some hacky hacks, and let me just steal my usual wait for v-blank code, which should really probably just be a macro. So let's wait for v-blank, then increase the scroll, the x scroll, which I am going to need to keep in a variable, so let's just make a new... Let's just make a new 0-page variable for that. So these are both 16-byte values, so this is using 03 and 04, so we need to start this at 05, and let's call it x scroll, and we'll live at 05. And let us default x scroll to where shall we set this? I'll set it right before we enter that loop. And we will set it to 0. And then I think what I want to do is just every v-blank, I'm going to increase it by 1. And this is just for testing, mind you, to get a good understanding, for me to get a good understanding of how this works and how our memory is laid out, video-wise. So, yes, let us load a 0 and store it into whatever I called that. Sorry, I slept 4 hours last night. It was called something. X scroll. There we go. So we clear our X scroll value. Then we will wait for v-blank, set scroll values, which, let me look back at that doc, I don't remember which one is first, X or Y. It is X position, then Y position. You write the same register twice, which is kind of a running theme in the PPU. There's a bunch of stuff that you do that, like this address register. So yes, X first. So let us... Nope, this wasn't the right location. I mean, it's fine there, but that's not where I intended to put it. That's way too early in the code. Here we go. Right before the echo loop. Alright, so we wait for v-blank. We will set our scroll values, so... I mean, I suppose I could really have just used a register instead of continuously reading from 0 page, because there's not much going on in this loop. So let's just do that. I'll leave the X scroll thing there at the top of the thing, but we could just do like load X. That's totally fine. Yeah, because we're using A for this stuff here, but that's the only thing we're using that for. So we'll set x to 0, and we'll use x as our scroll thing for this test. So store x to, what was it, 2005? It is 2005. 2005, and then I guess we'll do a load a. Actually, you know what? You know what else we can do? Keep using the registers that are available to us, eh? So load y 0 as well. And x will be our x and y will be our y. Wow, look at that. Store y 2005. And then, after that, we will increase x, and then I will transfer x into a so that we can compare that against what was the max value that it was saying. Max value for... Oh, I'm dumb. This isn't our x offset. Don't listen to me. This is our y offset. Whatever. Doesn't matter. I guess since I have to redo this anyway, or, you know, since this is meaningless anyway, I guess I can't remove that. And yeah, so x will be our x and y will be our y, but we want to increase y, actually. We're doing y scrolling. And finally, we'll compare that against 239, which, what is that in hex, just to be consistent? 239 is... Wow, nope, there was definitely some stuff still in the buffer there. 239. Hex is EF. So compare it against... I think... Yeah, what we'll do is if it wrapped over to F0, which would be the next value, then let's see. So if it's not equal to that value, then we'll just go to continue echo loop, which will be right here. Und. Otherwise, if it did equal F0, then I'm just going to clear it back to 0 and see if that wraps us back around properly. I'm not, as usual, I'm not going to think about this too hard. I'm just going to run it and see if I get a smooth looping of the screen. Or not. And if not, then it'll give us some clues on what's actually going on here. So, all we need to do is load y 0, and that is literally it. I'm pretty sure. If that's not it, then whoopsie doodles. Echo loop is already defined, I'm aware. Okay, I did something bad at... Oh. Continue echo loop. How did I manage to do that? It's by not getting any sleep. That's the magic. And at 188, it says... Wow. No, I want to transfer y to a. Symbol F0 is undefined. Of course it is. Because that needs to be a hex value. Oh, that was my last tonic water, and I will tell you, I have a thirst. But we gotta power through. Alright, any bets? Okay, scrolling, 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 and it just resets to 0. Interesting. Also, why is it not still going? That's interesting. Let's watch that one more time, just for fun. So it gets to the bottom. So apparently our scroll value of 239 or whatever that was just scrolls the second whatchamacallit, name table, so that its top is all the way to the top of the screen. And no further. It would appear if you scroll any further, but well, you can't. So, Trey, it would appear that that didn't work. That it doesn't wrap, rather. Trey says, maybe fill the first column of the name table with numbers so we can see it scroll. Sure. I think it's fairly clear what it's doing. But why not? What's the best way to do that? How many lines are there? Or how many characters are there vertically? 239. That would be 240 is the actual count divided by... So there's 120 pixels vertically? Is that correct? Does that make sense? Wait, no. 240 pixels per screen, right? You're like scrolling the whole distance of a screen is how far we scrolled, not two screens. So 240 is the height of screen. And 240 divided by an 8 pixel tall cell means that it is 30 cells tall. So I guess what we can do here is make a little loop. Trey says, do you have it set to do vertical scrolling? There's jumper on the hardware. Don't know about the emulator, a bit in the header. I believe Super Mario Brothers 3 does do vertical scrolling. I would be inclined to believe that. I think this basically confirms that just because. So this is one whole filled up name table that's filled with blanks. Then we have a whole, clearly a separate name table area that's all filled with A's. And you only have memory for 2 name tables. So if it were not vertically mirrored, we would see this same text again. Which leads me to an interesting thought, actually. God damn it. Okay, so I'm thinking right now, I don't think we can do software scrolling with the setup we have. And here's why. I'm making this work with the hacked Super Mario Brothers 3 cartridge. So I don't think... Let's look at MMC3 just to see if it has a vertical versus horizontal scrolling register in it. If it does, that would be awesome. Because, let me finish the thought that I was trying to get out there. I think if we had set it to horizontal mirroring instead of vertical, what we can do is because, or not mirroring, we want, yeah, because it's, right now, it's got horizontal mirroring, right? If we scrolled to the right, we should see the same things over here, you know, the text at the top and all those A's, as we do over here if we slid left and right, because it is horizontally mirrored. If we had it set to vertical mirroring, it would be the same thing, except we'd have the screen with the text, all of the A's to the side of it, and then below that would be those 2 screens repeated. So if we only looked at this screen and we scrolled vertically, we could scroll up one line, which would cause whatever text was here to get cut off, and then just clear that one line of memory, which would otherwise wrap around at the bottom, right? Because it's mirrored there. So we clear that top line, scroll, 30 pixels, and bing, bang, boom, you have scrolled. You just have to make sure that when you hit, a scroll of 230, well, when you hit the 240 increment that you reset your scrolling, that should work. But we don't have that kind of mirroring right now. So, hey, look at this right here. That's been sitting here. Oh, it's behind my head. Very good, very clever. Look at that. This is the page for the MMC3, and it says name table mirroring, horizontal or vertical, switchable, or for fixed. There we go. Okay, let's look at that horizontal and vertical register. Because if I swap it from horizontal mirroring to vertical mirroring, and we run this test again, we should just see that text loop over and over again. Yes, I feel confident about that. Mirroring is at register A000 to BFFE, all of the even addresses in that range. And it's just the low bit. So it defaults to... Let's see if I have my terminology backwards. I want to make dang sure before I do it. I mean, it's just a 1-bit change. It's just a 1-bit change, but... name table mirroring. So horizontal mirroring, like I said, is what we have right now. And I want vertical mirroring for what I was just talking about. So vertical mirroring was 0. So it's defaulting to 1 for whatever reason, apparently. Let us clear that to 0. So that should just be load A0, store A1000. Let's try it. Let's put this right here. Load A00. This is redundant because I could just use these X or Y values, but whatever. Store A to A1000. And unless they have what they've written backwards, which is entirely possible, I think we will get slightly different results this time. If not, we'll write a 1 to there and see if it does anything different. And if it does nothing, then we'll just stop trying to do hardware scrolling for now. Open. Basic.NES. Ho-ho! Now, I still don't know why it stops there. I'm going to have to look. But there you go. There you go. Yeah. Always, just a little late to the chat I am, because Narayan says, MMC3 supports 4 tables, no mirroring, but only if the cartridge has additional memory. I don't think... No, Super Mario Bros. Doesn't, and I only know that from having looked at the physical thing. Okay, so, yes, I think... And the nice thing about doing hardware scrolling that way is because we're actually offsetting where we're rendering in memory, like the offset of where we start rendering the screen relative to memory, our text still stays at the same memory addresses, and our like new line logic and all of that should be able to stay exactly the same. It's just that we have to check if we've gotten to the bottom of the screen, then we need to start doing hardware scrolling. Yeah, cool. All right. So for pretty much all of our, let's see, doodly doodly do, ding dong doodly do, ding dong doodly doodly do. Let's make like a little helper thing that always checks. Let me think about this. Because probably the easiest way, because once you've scrolled to the bottom of the screen, unless we like implement a clear screen function, which again, don't know if that's a thing BASIC has, don't know how it would be implemented if it was in there, but apart from having like a clear screen go to home command, like once you hit the bottom of the screen and start scrolling, you can't undo that. At least, you know, with this kind of old school text terminal. Like, you can't scroll back up. So what we can do, potentially, is just, like, set a flag. So when we hit the end, like, if we we hit the end of the line, gotta move to a new line, or we get a line feed character, we can make those both call into a little subroutine or, you know, little shared jump to code thing that will check to see, it'll check a flag to see, have we already started scrolling, in which case we just keep scrolling, we know we keep scrolling. And if we haven't started scrolling yet, check the Y portion of the screen address to see if we have hit the bottom of the screen yet. And if we are at the bottom of the screen, then set the, hey, we're scrolling flag to 1, then go to the same scrolling code that would happen if that flag was set anyway. That's what I'm thinking. So that way we don't have to keep doing the are we at the bottom of the screen check, because, yeah, we only have to do that once when we hit the bottom of the screen instead of keep checking, because, yeah, after that, we'll still be... I'll have to be careful about that too, because when we do that, I'll have to make sure we reset our character, our memory address that we're putting the next character to back to the top of the screen, which will not be physically rendered at the top of the screen at that time, but it will be in memory the first location of that name table, because that won't happen automatically. It'll start writing to the actually the attribute table, and we do not want that. So maybe I'm trying to decide. Maybe for starters, let's just implement some code on line feed. So if it was a line feed character, I'm just going to shoehorn it in here, and then we can move it around and commonize it once I kind of have it going. But let us, for starters, so if it was, then we go here, we increase the screen address by 20. Okay, so here's the spot really for starters. We would want to start before we... Ooh! Nobody yelled at me for this either. This actually isn't this easy. We need to back up a step. When we do a line feed, we can't just add 20. That will wrap eventually. That byte will wrap. We need to do the same thing that we did over here. And let's see. Yeah, so here, this is what we're doing when we manually print a character and it moves. So we increase X, which is the low byte of the screen address. We store it in the low byte of the screen address, basically the X coordinate. Then if it is not 0, I think. Yeah, if it's not 0, we hop over here, but oh, right. So if it wrapped to 0, we know that we rolled over and we need to increase the next byte of the screen address. And that's the important part here, is that can roll over. So basically, I need to check that here. So yeah, we need to... That is going to be funky. So we will add... Well, really, we need to check screen address first. Heck. Basically, we need to see if adding 20 to the current screen address low order bit byte would cause it to wrap. And if it would, then we need to wrap. We need to like zero out the top 3 bits of the low byte and increase the high byte. Which, as I describe it, is probably just the way to go. Like, we don't... let's get the screen address, and before we add, let us maybe and with... What would be the highest value there? Because we can't just like clear it out, because we may still have an X offset in there. In those low 5 bits. So, doodly doodly doo, ding dong doodly doo. Let me read chat. You have to do hardware scrolling or your scroll will be janky. Oh yeah, the software scrolling would be super janky and slow. As you get close to the bottom, you need to copy lines from the top of the viewport to the top of memory a line at a time, since you can't do more per view. Yeah, right, he's talking about software scrolling. Yeah, that's why it would be terrible. Simplify it, maintain cursor Y location, and check that. Yes, but here's the thing. In the screen address, we already have our Y location. Because everything is a power of 2, or because our X addresses are a nice round power of 2, the first 5 bits of that whole 16-bit value is the X value, and the rest is the Y value. So it's just so convenient that I want to keep using that. So you know what I want to do, I think, is load the screen address. Let's see. This is going to be the laziest thing ever, but I just can't think right now, even though, again, the math here is really pretty straightforward. I'm just going to keep adding 20x until it rolls over so that I know. Like, it's going to do it clean, right? Oh, yeah, it just did it, right? So I'm trying to figure out if I might not even need to, like, it's just going to potentially naturally wrap. Clear. So 20 plus 20 plus 20 plus 20 plus 20 plus 20 plus 20. Yes, because when we add this, it's just gonna be F0. Yep. So plus 20. Yes, it rolls over nice and clean. So I think we can. Yeah. What we can do. This is much easier than I'm making it out to be. We'll load the low screen address byte, add 20 to it, and we can store that. But then also we can check by anding with E0, because that is everything but the low. Like, we don't care what's in those low 5 bits. That's the X address. The X address might have some offset. We're not worried about that. But if the top rest, if those top 3 bits are now 0, we need to increase the high screen address. Yeah. So I can just use branch not equal. So that's branch if not 0 to print char end, because nothing needs to be done. But if it does need to wrap, then we just load a screen address plus 1, which is the high byte of the address. Actually, easier way to do this is load x, increase x, store x to screen address plus 1. And what we can do is literally just comment these out really quick, just to do a little test. And if we let's just print, that's what we'll do. I'm going to I'm just gonna do a loop printing like a character and then a new carriage return new line several times. You know what we can do? Let's take this, the here string, put it here, just because that's at the beginning of the line, so I think it'll look a little bit nicer. And we can make this a little loop really quick. So let's call that print loop, and we probably need to save some variables. I'm going to put my iterator in, I don't know, x. So store x, start at, I don't know, we'll just print this a few times because it should only take a handful of times for the math to go wonky, and basically the text should start wrapping on screen because we're not increasing the y value when we're supposed to. So it should pop back up because I disabled the fix. So I just need to prove that the fix did something. So let's, I don't know, repeat. We have 30 lines, and I don't want to exceed that because I don't want to get into where it would start scrolling, and at that point it would actually start overwriting the attribute area, which would not be good. So let's, 16 lines, sure. So we print the here string. Oh, there was a minor bug. That didn't actually affect anything because those are in the same page, but whoops, high byte of that was not being set correctly. Anyway, so we'll print that string, we'll print new line form feed, and then decrease x and branch if not 0 to print loop. And that should give us 16 of those printed to the screen, which should totes F up. Uh, 157. What did I screw up? That is backwards. Literal then hex. Illegal addressing mode at 157. Yes, that doesn't make any sense, does it? Load X. Okay. Fingers crossed we get 16 copies of here. Yay! Oh, and then it does the scrolling bit. Cool, cool. That is not 16, though. 1, 2, 3, 4, 5, 6, 7. Oh, wait. Wait. That would be 16, right? Yeah, man. What's this? 1, 2, 3, 4. Oh, because it's doing the wrapping, you dummy. Duh. That makes sense. Yes, so it prints 1, 2, 3, 4, 5, 6, 7 copies of the thing, and then the Y value wraps because we're not increasing the high order byte of the address. So if we print that fix, we should actually get 16 of them. So let us re-enable the fix right here. Still screwy. Also, it's kind of funky because it doesn't, like, it gets the last one and there's no delay. It just immediately gets to the scroll part. So there's something up here. I'm doing something silly. Because I was saying I'm probably clobbering. Yeah, I'm totally clobbering my X register somewhere in here, or rather, the subroutines here are using X and it's getting clobbered. So, whoopsie whoops. Totally meant to do that. So I should, I guess right at the top of the loop, really, I can push X, and then when we're done calling all of the subroutines, then we can pull X. Oh, those aren't things, right? That's true, isn't it? So we actually need to pull A, T, A, X, and same deal here. Transfer X into A and push A. There we go. And let's turn that fix back off. Oh, where was that? check line feed, and it's all of this stuff. There we go. See how there was like a delay in there? That's where it was printing over itself. Very good. So, now let's enable the fix. And see that it actually fixed things. Didn't fix shit. There's definitely still that delay there, but that didn't do a damn thing. Let's check to see if and sets the 0 flag, because it might not. That seems weird to me, but could be. Oh boy. Yeah. And is just like a regular word, isn't it? Here we are. No, it totally sets the 0 flag. Interesting. Interesting, fascinating, interesting. Let's just go ahead and basically, I'm thinking I want to put a break here, but I only want it to break when this actually wraps. But it doesn't seem to actually be triggering, so yeah. About that. Oh! Did you see that? Because I didn't see that. We're saving A to screen address, which is totally wrong. Let's try this fixed fix again. That would do it. Yay! And I noted an interesting thing. Oh, no. That went right back to the correct top. Right back to pixel 0. Lovely! Let me watch that one more time. That was very satisfying. All right. Now, to the actual scrolling part. So, let me get back to chat real quick, and actually, you know what I'm thinking. It's been pretty much exactly an hour, so without trying to be too much of a party pooper, it is a regular weekday. I am, theoretically, my dad is coming over here tomorrow, and we are going to work on building those deck stairs, so I should probably get to sleep. So as much as I would like to start writing that the actual software scroll, check and scroll logic into here, I think I'm going to have to hold off till probably Sunday, because tomorrow I'm probably going to be frickin' bushed. But let me read chat, and then I will disappointingly get out of here. Yep, just a couple Narion commentos. In FEID, can you check the PPU viewer to see what it... in FCEUX, can you check the PPU viewer to see what it does? There is surprisingly little in the PPU viewer, actually. Actually, there is a... I know you're like commenting on things that are old news at this point, but it does have this name table viewer, and you can kind of see... It's really poorly rendered. Yeah, you probably can't really see it on screen, but it kind of gives you a frame for like what's being shown on the screen right now, and clearly it shows you how the mirroring is set up. But hey, yeah, so as not to be too disappointing, let's do the usual slap it on the ROM and run it on the real thing real quick. So let me do that. Then I'm going to go to bed, you guys. Thank you for hanging out. And I got pretty much where I wanted to do today. It was those two control characters, which technically are both working perfectly right now. and maybe scrolling. That's what I put in the description. And we started playing with scrolling, and I have a good I have a good plan for actually implementing it when I get back to this. So, let me go get that thing. Oh man, very bushed, but I'm very satisfied today because I think I've mentioned before on here I'm doing some freelance work, and it's the first time in my life that I'm doing some freelance work on the side. I'm very excited about it because, you know, I mean, it's extra income, and that's nice. I don't need to or want to be rich, and surely I already have more than I need. But if I can wrangle this into like getting my house paid off early and like semi-retire, I mean, that is clearly a luxury that is available to very few, but I'm in that lucky situation, so that, you know, it might seem funny to you because I'm doing a daily stream thing, but I'm doing this for fun. I'd be doing this anyway. This is why I'm streaming it, because I'm like, oh, you know what? I could stick a camera in front of me, and it's just what I'd be doing anyway. So, anyway, like, if I could get the house paid off and whatnot, and maybe pay for, you know, just my day-to-day by doing kind of part-time freelance work, man, that would be the dream, and that's what I'm angling for. Anyway, never freelanced before, and I've been nervous about I'm working on retainer. You know, basically you ask for a big payment up front, and then you work through that. You know, you bill hours to that until you run out, and then you ask for some more. And I have been nervous to ask for my second retainer allotment, because it has been time for a little while. And I did it, and they paid me, and it feels good, man. So that is... I cannot complain about anything right now. Things are going very good. And I can only hope that, you know, things are going or will go good for everyone else out there. But can't remember why I got on that tangent. Just it was a nice thing today, and I was so worried and self-conscious about it that they wouldn't like my work enough that they'd be, you know, unwilling to pay me. But no. Without a word, all of a sudden there was another payment in my bank account. That's very satisfying. I do very much need to pay my taxes, though. Oh, I got to get used to making quarterly estimated taxes. Find that zip, or should we order one for you? I'm just... 1 second. This is going to be dumb. This is going to be dumb if I find it. Hi. It was right here. Oh, no. Hold up. Okay. Woo! For a second, I was worried that it was soldered in. It's right here. It's right here. It was in this drawer the whole time. Why didn't I look there? And is it going to be too many pins? No, it is a 32 pin. Here. Yeah, buddy. Okay. And it might even... I was worried about this overhang, but it might even actually kind of sort of fit in the thingy. But can I get it into the socket? Oh boy. Now this is hairy. Because these pins they're wide this way, not this way. So not the way it wants to go in. But all I need to do is get it in once. I am not beyond using violence to make this happen, if that's necessary. No, that is really not happening. Well, Trey, sorry I just yelled directly into the mic. Fast up and fast down on that one. Oh, we can still probably get that to work. It's right there now. We have it. I'm going to keep it on this bench. Right in front of the camera right here. So that you always know it's here. But yeah, doing that, I was starting to, you can maybe kind of see, bend the pins on that, so. No. Do not apologize, Trey. The Ziff is a fantastic idea. It just refuses to work with us. Okay. Nope. I love how every time I accidentally switch to the close-up of my face, I'm just going... Very attractive. We're writing to the thingy. The thingy. We're writing to the thingy. And we're done. Doodly doodly doo. Can you tell I'm sleepy? Can you tell I'm a sleepy man? And hopefully this still makes contact and I didn't fudge up all the pins. No, that feels okay. That feels okay. Doesn't look like I broke anything too bad with all that banging. Okay. Let me see really quick. Can this camera... Whoa, sorry. Kind of forgot that that was the active camera. Can I use this one? Sorry, to look over at the TV. I can't. I'm just going to do this because this little webcam is way easier to move than the camera on the tripod. Sorry, Dirt Piper got to me. Writing EPROMs at 10:42 p.m. on a Friday. Living La Vida Loca, baby. That is right. Her lips are devil red and her name is Nintendo. Should be good to go. One would think. Seems to be doing nothing, sir. It's not plugged in, my guy. It's not plugged in. This is why I need to go to bed. It's bedtime for this guy. This is why I shouldn't feel too nervous about the freelance work, because you know why I got 4 hours of sleep last night? Yeah. Not that that's a healthy thing that I recommend doing. I am really not generally that kind of person. But I'm also a huge procrastinator, so sometimes it happens. Okay, cross your fingers. I'm standing directly in front of it. Let me fix that. Okay, nothing. But in a slightly more interesting way. Wait. It's still not. Give me juice, man. What the heck? That's plugged in. This is plugged into this. That is plugged into the power strip, which is currently powering... Yeah, it is currently powering the audio interface that is connected to the computer and bringing you the beautiful sounds of my voice. Let's just try putting it directly into the power strip. What the heck, bro? I know I didn't put the trigger back. Oh! Almost caught that on camera. Almost bit it. But we have power now. I don't know. Horribly bad extension cable? Oops. Okay, in she goes again. And it's on. Fascinating. I clearly have a bad connection somewhere. effed up power cable or something. What, dude? This is seriously spooky. I mean, it could be related to the fact that I turned this chip around last time. Maybe the NES was not a big fan of that. Hopefully I haven't fried this NES, but you think it would like just notch power on it. That. Although it. Mystery for next time. Did we kill it? I mean, it was running. It was running like since the last time we were doing this, I had this just sitting here on for a while. So, maybe I finally fried the whole thing, which would be a real bummer. But okay, my apologies. No real hardware version today. I will firstly get my face back on camera. I will fiddle with that off screen to try and figure out what the hell is going on there. That's concerning. I hope I didn't fry an NES, but we didn't make any modifications to the NES, so worst case scenario, I spend what, like another $50 on an NES and start over again, but that's still freaking lame. Anyway, sorry. That is, what's the word I'm looking for? Disappointment is too easy of a word. There's a better term, but I'm in need of sleep. So, see you guys. Like I said, won't be on tomorrow. Gonna be building deck stairs tomorrow. And hopefully that won't go into Sunday, but we will see. But I'll do something this weekend. Anyway, Trey says couldn't be the violent pounding. Of course not. Couldn't be. Yeah. I probably broke it. Given my history, I probably broke it. All right. See ya. Love ya. Bye-bye.